Adsorption process is defined as the deposition of molecular species onto the surface, and the molecular species that gets adsorbed on the surface is known as adsorbates. So the adsorbates can be ion, liquid, or gas. And the surface on which the adsorption occurs is also known as adsorbent. Let's say we have the adsorbent here and we have the adsorbates. When the adsorbates is being adsorbed, it happens only on the surface of the adsorbents. This is a surface phenomenon. And what will happen is that when the adsorbates is being diffused out, we can see the desorption has happened in the system. There are two kinds of adsorption happen in a system. The first one here, we have monolayer adsorption, and we have also multilayer adsorption. What is monolayer and multilayer adsorption? Here we have on monolayer adsorption, the adsorbed molecules are in contact with the surface layer of the adsorbents. So here only we have a single layer of the adsorbate and adsorbents contact. And for the multi-layer here, not all adsorbed molecules are in contact with the surface of the adsorbents. Okay, so here we have a first layer, here we have the second layer, and here we have the third layer. So different layer of adsorption happen in this system, but only first layer is in contact with the adsorbents. Type of adsorption. Here we have two types of adsorption. The first one is physical adsorption, or in short physisorption, and second one we have the chemical adsorption or chemisorption. For the physisorption, we have weak van der Waals forces and no activation energy is required for the bond breaking and bond formation, and it is favorable at low temperature, and the process is reversible, and the adsorbed amount increases as the pressure increases. And we can see here the physisorption having a multi-layer adsorption. Okay, this one is the first layer, this one is second, third, fourth, and so on. And for the chemical adsorption is in the opposite way. For the physical adsorption, we have here the strong chemical bonding. Okay, and it is require activation energy for the bond breaking and bond formation, and the favorable at high temperature, irreversible process, and pressure is not significant in this case. And as we can see here, the adsorption or the chemisorption having a monolayer, where the first layer is in contact with the adsorbent here. Adsorption isotherm is the study on the relationship between the amounts of adsorbate being adsorbed on the surface of adsorbent and its pressure at a constant temperature. So here we have three types of adsorption isotherm. The first one is the Langmuir, the second one is the Freundlich, and the third one is the Brunner, Amann, and Taylor, what we call as BET. These are the adsorption isotherm that is found by the scientists previously. Okay, now let's take a look at the Langmuir adsorption isotherm first. Langmuir isotherm describes a monolayer adsorption in which the volume of gas molecule adsorbed at a certain pressure. These are based on the four assumptions, and the first one is the solid surface of adsorbent is uniform. Okay, in this case, all the adsorption sites are equivalent and every sites have the same energy or homogeneous surface. So here we have the adsorbents and we have the adsorbates. Here is the adsorption sites for the adsorbates. Okay, and all of these sites are equivalent with homogeneous surface with the same energy also. And the adsorbed molecules did not interact with each other, and the adsorption is localized. The adsorption is not moving, and the adsorption occurs through the same mechanism, and a maximum of one monolayer or one single layer, one adsorbate molecule per site can be adsorbed. Okay, and the adsorption cannot proceed above the monolayer coverage. For Freundlich adsorption isotherm, it is about the empirical relationship between the amount of gas adsorbed by a unit mass of a solid adsorbent and pressure at a particular temperature. Here, empirical means that It is observed in the experimental, okay, based on the experimental. For BET or Brunner-Emmett-Taylor, the BET isotherm describes a multi-layer adsorption in which the volume of gas molecule adsorbed at a certain pressure. In this case, the attachment of molecules directly on the solid surface of the adsorbent and the attachment of molecules to the adsorption sites, which are already occupied by the adsorbed molecules, forming the second layer, third layer, and so on.